Ladies and gentlemen, we're starting with electric circuit. We're starting with what we call an electric circuit. This is a topic which is examinable. So you'll find this topic in your exam. So we're going to start slowly, then we'll move fast, just like a takeoff of a flight. You understand? Like the takeoff of a flight. So we're going to move, it starts slowly, then it increases the speed while it is on the runway, and like that it takes off. So we're going to talk about electric circuit. I'm going to make sure that I start by picking up some of the things that we did in grade 10. I also take the things that we did in grade 11, then I move you to grade 12. Then in that way, we'll be able to flow together and move together. When we talk about the electric circuit, what is it that we are talking about? We need to bring it home. What is an electric circuit? What picture comes in your mind when we talk about the electric circuit? You see where we are in this classroom. There is an electric circuit. An electric circuit is when we have a source of energy which is connected to what? To wires. You understand? And along those wires there are resistors and many different things. Just like in this class, we've got bulbs, right? They are connected to electrical cords, right? It means that is an electric circuit. At your home, you have got a fridge. That fridge, you plug it on an electric socket. So that connection is a what? It's an electric circuit. So when we talk about electric circuit, it's what you do at home. You plug in your TV. Plug in your TV game, charging your phone. When you charge your phone, you create a what? An electric circuit. And you know what the charger does? The reason you put a charger and charge your phone is the charger reduces that the amount of electricity that goes into your phone. You know that we've got different chargers with different voltages, right? So if you can put a larger voltage on a phone which needs a smaller voltage, the battery may burst of that phone, right? Yeah. So that connection of electricity at your home in this class, it is an electric circuit. So I know that whenever we talk about electric circuit, people want it to resemble like in this fashion. So, just bring it home, right? One will say that the electric cord at my home, it is not like that. What you need to know, in that electric cord at home, there's a positive wire and a negative wire. If the electric cord is just like this, it is insulated just like this. You may see as if it's only one cord, but inside those insulators, there are two wires inside there, right? Yeah. Which is negative and positive. So you need to know that if you take a wire, you plug a stove on the socket, the plugs there on the socket. It means you did what? An electric circuit. Electricity will flow going to the opposite direction and coming back, right? And it will flow in that way. And so you have created an electric circuit. So an electric circuit is not just this diagram. Whenever we are plugging things, plugging a TV, charging a phone, that's an electric circuit because we have got what? Wires, right? Yeah. So that is an electric circuit. We're fine, right? We understand what is an electric circuit. So the first thing you need to know what an electric circuit is, and which I've explained to you that an electric circuit is that connection of wire that we have even in this class. These bulbs, when you make the switch to be on, the lights are going to go on, right? It's because there is a connection, and that connection we call it a what? The electric circuit. We're good, right? Okay. So now, as we're speaking about we've spoken about electric circuit, and I'm sure in your mind you're starting to see a picture of the electric circuit. There are three things that we are going to emphasize on in this topic of electricity. There are three things which we are going to do to emphasize. The first one is what we call the current. The first one is what we call the current. So I'm going to explain these things just loosely, bit by bit, bit by bit. You need to take each and every point, because after learning these things in parts, we are going to apply the very same information in the whole complicated electric circuit, right? There's what we call what? Current. What is the current? Current is the amount of charges. The amount of charges. The amount of charges that flows. That flows past a point in a second. In a second per unit time. Current is what? The amount of charges that flows and pass a particular point in a second per unit time. So it means a live wire. A live wire is the one which you can touch and you get an electric shock, right? Yeah. It is live because there is electric current. And what is electric current? It is the charges, right? The charges are moving in that wire. Charges are flowing in that wire. So it means a live wire has got what? A current. Current, which is the what? The charges. These charges are moving on that wire, that electric cord. The charges are moving, right? So we say the amount of charges that flow past a point in a second per unit time. It means we can represent current like this. We use letter I. We use letter I to represent current. Whenever you see letter I, it means we are talking about the current. We use letter I to represent current. Meaning that we can state this statement mathematically so. We can say I, which is current. I is equals to the charge, change in charge, over change in time. Because remember Q, it represents the what? The charge, right? So in this statement I say is the charge per unit time. The charges that pass a particular point at a given time. You understand? So we can represent current like this. This statement is just the definition. You understand? When we say there is current, what is happening? It means charges are flowing on that electric cord. You understand, right? Okay. Okay. We are continuing. We are continuing. So let us continue in that fashion. As we have stated that current is the amount of charges that flow past a point in a second per unit time. Right? Yeah. So, the SI unit, as I said, that I is a symbol that represents current, right? Yeah. The SI unit for current is what? The SI unit for current is what? Is what? Is what? It's ammeter. It is amperes. It is what? Amperes, which we represent by capital letter A. Capital letter stands for amperes. Amperes, right? We represent it by capital letter A. It is the SI unit of what? Of current. So, I heard you saying that it is ammeter. Let us clear the confusion. Most of the time, when they give you an electric circuit, a representation, what they will do is that they will write A, right? That A will not be representing ampere. It will be representing an ammeter. What is an ammeter? An ammeter is an instrument that we use to measure the amount of current. You understand? Yeah. An ammeter is the instrument that we use to measure the amount of current. So, an ammeter is an instrument. It's an instrument to measure the amount of current. So it means one can come with that instrument. One can come with that what? But usually they use a multimeter. We have a multimeter. I will show you the multimeter. I'll come with it tomorrow. The multimeter. That multimeter, it is called the multimeter because it can measure different things. It can measure the voltage. It can work as an ammeter. It can work as anything, right? So they come with that thing and they plug it on the electric cord. Then it will tell them how much current there is in that cord. You understand? So it's an instrument. We're good, right? Yeah. Current. We're fine. We've understood what is happening with current. We can talk about something else, right? Yes. These are general statements, right? These are what? General statements. After explaining each and every one of them, I'm going to tell you how does current behave in a parallel circuit. How does current behave in a series connection? You understand, right? I will tell you. Okay, we're good. So let us erase this. Now, we can talk about what? What else can we do? I said we're going to emphasize on 3 things. What is the third thing? The second thing? Potential difference. Potential difference. I know that most of the kids, they've got the tendency to call potential difference voltage. But sometimes it makes sense because the SI unit for potential difference is voltage. But we usually call it the volts, right? Potential difference. Potential difference is simply the work done per unit, the work done per unit charge to move a unit charge between two points. So if we've got 2 points, we can define potential difference in this way. If we've got point A and point B, we can say the work done per unit charge to move a unit charge between 2 points. Understand, right? You need to take note that in our exam guideline, we won't be asked the definitions of this. Now we're just learning this for us to understand. Because we can't just teach things coming from the air. And we see this one is coming from the air and we start to explain. Everything which is physics, it must come from somewhere, right? Not the air. So note that our exam guideline does not tell us that this is going to be asked. You're not going to be asked to define this. We're good. We're good, right? Yes. But listen. The fact that you won't be asked to define this, it does not mean you will not use this. We'll use this. If we're learning about electric circuit, we use the potential difference. We use the current. You understand? Eh? So you need to know what is happening. How do they behave? Because if you can jump and you forget to master how current behave, how voltage behave, you won't understand to solve situation with the electric circuit. So you need to understand, right? But you won't be asked to define. Okay, thank you. So what is it that the potential difference is doing? You know what the potential difference is doing? It's going to pump charges. It is going to pump charges. Remember those charges that moves, they are called what? Current. But they move, they are driven because of the what? Of the voltage. It means when I connect the voltage, it means current will start to what? To move. Why is it moving? Because I've connected the potential difference. The potential difference, its work is to do what? Is to pump the charges. Its work is to make sure that the charges start to flow. So the potential difference drives the charges. The charges cannot move without the what? Without the potential difference. Even if charges may be there, but those charges will not be able to move. They need what? A driver. And that driver is the potential difference. The work of the potential difference is to pump the charges. That's why we say that it is the work done. It is the work done per unit charge to move a unit charge between 2 points. So it means we'll be moving, if we have 2 points, point A and point B, we'll be moving a charge from this point A to point B. We're moving the charges because of the voltage. You understand, right? So the SI unit for potential difference, SI unit for potential difference is what? Is volt. And we represent by symbol V. Some they can say letter V. The SI unit, it is a V. So if we want to state this definition mathematical, we can write that V, which is the potential difference, is what? It is the work done to move a unit charge. We can say V is equals to work done divided by the unit charge. You can simplify it in that way. But still good, right? Okay. Let us talk about resistance. Let's talk about resistance. Okay. No. I'm not. Oh, okay. Let me just give you a chance to write, right? Okay, sure. Okay. We're done about to explain what is the potential difference. I want us to talk about resistance. Resistance. We talk about the what? The resistance. Usually, they use the letter R to represent the resistance, but let us not dwell on that. They usually use letter R to represent the resistance, right? They use this symbol. It's a symbol. Then the second thing about the resistance is that the SI unit is called what? Ohms. It's called ohms. So this thing, if you have an Omega radio, Omega brand at home, you'll see something like this, ohms. So it's a symbol which is a bit difficult to write using a hand. It's this special symbol which represents ohms. It looks like a drawing of a head, like that head of the Undertaker. Yeah, something like that. Something like that. So it's the ohms, the SI unit. But we need to understand what resistance is about when we've brought the information back home. Understand in our own way. What is it that resistance is? What is resistance? Do you know what is the meaning of resist? The word resist, it means to do what? To oppose, like to refuse, né? To resist. It's like if I say come, and you don't want to come, you're resisting, right? Okay, the resistance, as I've told you, the SI unit for resistance is ohms, right? Okay, so now I want us to explain, to talk about the fact of what is happening with this resistance. What is resistance? Look, the word to resist is an English word that we know that it means to refuse, right? To refuse, to oppose. That is to resist, right? And sometimes we talk about friction. If an object is moving in this direction, friction will be opposing the motion. It means the friction is also a what? A resistance. You understand? So, what does this resistance resist? You know, if current is flowing in this direction, right? Resistance will be ensuring that the current that is supposed to flow in this direction, it does not flow this direction. Resistance resists the current. It resists the flow of charges. It means where there is resistance, current will also be minimal. Current will be reduced because the work of resistance is to minimize the what? The current. So whenever there is resistance, current will be less because the work of the resistance is to resist the what? The current. You understand? So we can even talk about relationship between current and resistance. What is that relationship between current and resistance? It's inversely proportional, right? Current is inversely proportional. Current is inversely proportional to resistance. What does this inversely proportional mean? It means when current increase, right? Resistance decrease. When current increase, it means resistance decrease. So that is the relationship between current and resistance. It means when we have got a high resistance, it means that current will be less because the work of the resistance is to resist the what? The current. Then let us even bring it home further. This resistance, where can we find resistance? Practically so. In this classroom, at home, or anywhere. Do you know your charger? Do you know that charger of yours? Do you know it is a resistor? Look, in this electric socket, if I put the twin plug in my charger there, you know the charger will do what? It will reduce the amount of current that must go to my phone. The charger is going to do what? To reduce. You know that the current that is flowing there at home in the electric socket, it is high, right? So the reason you put the charger, the work of the charger, it is going to act as a resistor. It is going to do what? To reduce the current so that your phone can be able to charge without bursting. You understand? That's why sometimes with other phones, if you use a different charger, you find that your phone bursted, no longer works, right? Because you have supplied it with a high voltage. So the work of the charger is to reduce the current flowing. That is an example for resistance, the charger. You understand? Another resistor, you see this bulb that we have in this classroom? It's another resistor. It is going to do what? To resist the current. You understand? A stove, the stove that you have at home. Do you know that it is a resistor? It is a resistor. It reduces the current. Anything that you plug at your home, a TV, is a what? It's a resistor. Okay. You know this, the electric lines, you know them, right? Even here, that side was an electric line, which is moving like very long kilometers, right? Making sure that there is enough supply of electricity in our villages, in our towns, in our country, right? You know that the current that is flowing in those electric lines, it is greater than the current that is in your house. Do you know that? But the electricity which is in your house was taken from that electric line. Why is there a difference? It's because when we just take electricity from the main line, we're going to put it in the meter box, that box that you have at home, right? That meter box is a resistor on its own. It is going to reduce the amount of current which is going to flow, meaning that we are going to have a minimal amount of current inside the what? Inside the house. You understand what resistor is? You understand how a resistor behaves, right? Yeah. Well, good. So we've spoken about what? Current, resistance, potential, difference. And all these things, they were invented by one man, and we're going to talk about his law. Listen, my people, this law, it is examinable. It can be asked in the exam. We are coming. Ohm's law. You need to know Ohm's law. It is examinable, right? It is rare to find an exam without Ohm's law. Remember that when we state laws and definitions, we don't just define something, we use a definition from the perspective of any textbook. We use the exam guideline, right? What does Ohm's law say? It says that, it's simple. It says the potential difference across a conductor. The potential difference across a conductor is directly proportional. Is directly proportional to the current. To the current in the conductor. It's directly proportional to the current in the conductor at a constant temperature. At a constant temperature. So, when you are requested to state Ohm's law, you must not omit even a single word to get full marks. Ohm's law states that potential difference across a conductor is directly proportional to the current in the conductor at a constant temperature. And it is easy, it's not difficult, right? You can even know it by just reading it only one time, and suddenly you know everything. We're good, right? The potential difference across a conductor is directly proportional to the current of the conductor at a constant temperature. So, this guy called Ohm, he came with this law. Actually, he came with the things that were explained. He came with this law. This law, if we state it mathematically, I can sum it in this triangle, which is given by VIR. you will notice that these are the things that we've been explaining. The potential difference, which is in voltage, current represented by symbol I, R, which represent the resistance. So, if ever we want to get something, okay, so this triangle, some Ohm's law. How do we use this triangle? If you want to calculate voltage, you just close where there is a V, right? It means V is equal to, when we close V, we're going to be left with I multiplied by R. I multiplied by R. If we want to calculate I, we just close I. It means I is equal to V over R. If we want to calculate the R, we're going to close R and we're left with V over I, which is V over I. So this is basically Ohm's law. That is Ohm's law. Those formulas, you will see us using them even when we deal with power. Okay, ladies and gentlemen, we have explained Ohm's law. Ever since the start of the lesson, we were explaining Ohm's law. So now we're going to further explain Ohm's law, what is happening with Ohm's law. Here is the first thing. Let us talk about current. How does current behave? Here is the main important point, right? You will not be able to get answers in an electric circuit if you fail to understand the statement which I'm going to make. We are good, right? Actually, you don't have to understand it, you need to know it. Because there's a difference between knowing something and understanding it. Someone will say, how do you know something without understanding it? I know it, I don't even understand the statement. Yeah. Okay. Here is current. You are good, right? Yeah. So, current does not flow in an incomplete circuit. I know you who are watching online, sometimes you say you can't see what I'm writing. Whatever that I write, I say it with my mouth. I just say current does not flow in an incomplete circuit. Whatever that I write, I'm saying it verbally. So you must write what I say if sometimes you fail to see. Thank you. Okay, this statement is very powerful. Ne? You will see. Let me repeat it. Current does not flow in an incomplete circuit. Let me just give you an example. Let's take this. It's a circuit. Ne? Circuit, then the circuit is like this. Yeah. Let me immediately teach you that. This is a switch, you know, we call this a switch. So when the switch is like this, we say the switch is open. Open. We say the switch is open. This switch is the same switch that you have there at your home, the one you use to switch the light on in your room. You just say tap. When you switch off, tap. Just like that, by pressing, right? So you can see they're the same. It's a switch, right? So when this switch is open, it means the circuit is not complete. The circuit is incomplete. What do we mean by a complete and incomplete circuit? When we talk about a complete circuit, it's a circuit which does not cut the flow of charges. You can see that the charges, they circulate in a complete circuit. You understand? The charges, they circulate. But the problem here, charges cannot circulate. They will move. Just an example, just an idea. But in ideal situation, they will not move because the circuit is open. Okay. But for the sake of explaining, let's say charges are moving. They will move here. But because there is no connection between this side and this side, it means the current will not flow because this circuit will say it is what? incomplete. You understand? Yeah. Let me just give you the situation at your home, and you know it exactly. You know that your stove at home, there is where they put a slow tape, right? We know, I'm starting to prophesy here. Can I prophesy? That stove at your home, it have got a slow tape there. Ne? So what is happening? What is happening? Sometimes you find that we put the slow tape to connect things, right? Yeah, we put the slow tape. So let me give you an example. Let's take we've got the stove. We've got a stove like this. This is the stove. This is the stove. You can see it's a stove, right? Then this is that's where we put the cord of a stove. We put it here. Then it starts to work. This stove will start to work while baking. If ever this cord can be cut like this, current is not going to move from this side to this side, right? Because it is cut, right? Okay. And that is obvious because you will even say that no, the current will just be here. The current will be on this side, right? Okay. But let me just give you an example. You know that I told you that the electric cord, there are two wires inside, right? So let me just draw those two wires. You see, current is flowing within the positive and the negative wire. There is a flow of charges, right? So if one wire is cut, the other one is not cut, will the charges flow? The charges will not flow. Test it at home. Let me just explain this in Shitsong. One and a half. Only one part. You know that, right? Matter why she got it? Because current does not flow in an incomplete circuit. In order for current to flow, the current will not do what? Will not flow. It means current will not go that side where there is a what? The wires are separated, because current will only flow in a complete circuit. I've explained to you what a circuit is, right? I've told you that even your charger, when you plug it, it becomes a circuit, right, with your phone. There's a flow of charges, right, which circulates and rotate, come back again. You understand, right? So this statement is very important. You need to keep it in your mind that current does not flow in an incomplete circuit. So you'll be given a question and an incomplete circuit comes, and I know you're going to be solving, getting answers. How do you get them? Because current cannot flow when there is what? Incomplete circuit, but yourself will get answers. Okay, we don't know, it's fine. Okay, let me just extend this circuit. Let's take the circuit is like this. Okay, let me put an ammeter there. Let me put a resistor there. Resistor. Okay. Do you see this? Do you see this? Let me put another ammeter here. Do you see this? If we can have a situation like this, current will not flow this side. Do you agree? Current will not do what? But where the circuit is complete, current can do what? Can flow. You understand? Yeah. So it's like the other part which is incomplete will appear to be there. Then the other part which is complete, current will be flowing. You understand? Yeah. Okay. Let me do it like this to avoid the confusion. Let me open the circuit somewhere here. Understand, right? Yeah. Okay. This is a resistor. Resistor R. And you see that? So, how will current flow? Current will flow here. Will current go here? No, it will not go, because current does not flow in an incomplete circuit. So it means current will flow here. And it moves here. It returns. It won't come this side. You understand? it won't come this side. Why? Because this switch is open. So whenever you see an open switch, what will be the reading on the ammeter? Not this, not, okay. Ammeter 1. Ammeter 1, this is ammeter 2. What will be the reading on ammeter 1? 0. It will be 0 because the current does not flow in an incomplete circuit. You understand, right? It's a powerful statement you can ever know. That's how we interpret. It's a powerful statement you can ever know for this electric circuit. You need to know that current does not flow in an incomplete circuit. Whenever the circuit is incomplete, just know that current will not go there. So sometimes you will be told that the switch is open. You are requested to calculate the information here. And sometimes they trick you. They put resistor 2 here. They say calculate the resistance, resistor 2. What is the resistance here? 0. Why? Because there will not be any flow of current this side because the switch is open. Current does not flow in an incomplete circuit. It's a statement which you're going to use to interpret many different things. It's a point number 1. The other part we're explaining general, right? Now we're explaining in order to interpret. We're explaining in order to interpret. First point that we have taken. Current does not flow in an incomplete circuit. We're good, right?
Yes.
I see you are starting to understand. But the problem... Okay. We're going back to the work that we did in grade 11, right? I remember well that in grade 11 I told you parallel connection and series connection, right? For the sake of interpretation, I'm not going to separate parallel and series. I'm going to teach them simultaneously at the same time because this information, we are learning it for us to be able to interpret a circuit that is going to be sent to us in grade 12. We're good, right? Yes. Okay, let us talk about current. How does current behave? Current in series. Current in series. Remember when we talk about series, we're talking about things which are following each other in that way. You understand? That is what? Series. They are following each other like this. They are in series, right? Yes. So, this is an example of a series connection. This is a series connection, right? So, what can we say about current in series? Current in series, right? Current is the same. Is the same in all resistors. They can say calculate the current here. It is the same, right? Current is the same also here. Current is the same in series. Current is the same in all the resistors. Actually, in every point, or I can say in every point of the wire. Current is the same in every point of the wire, right? Meaning that the current that is here is the same as the current that is here. The current that is here is the same as the current that is here. The current that is here is the same as the current that is here. Listen, my people. What I'm teaching you now, it is to interpret, right? Yes. You won't be asked this thing, the current that is the same here is the same as the current is the same. You won't be asked that. But you need to know it in order for you to get the answer for the question that you will be asked, right? It is interpretation. It's something that happens in your mind. The problem is we cannot see what is happening in your mind. I'm not sure if these things are being instilled in you. This way of interpreting. You get it, right? So in series, it's like water. You know water at home, the hose pipe. You have a hose pipe at home, right? Even if you don't have, you have seen it before. Even here at school, we have hose pipes, right? If I have a hose pipe from this point to this point, when A and B, the amount of water which will flow here, it will be the same amount of water which will flow here. it will be the same amount of water that will flow here. You understand, right? Yes. Because that hose pipe, it creates what? It is connected in a series connection. It is possible to make a hose pipe to be in parallel connection. We'll explain about that. So this is a series. Series is like a line, right? A series is a what? It's a line of things following each other. So it means the amount of water that is here, it is the same as the amount of water here and here. You understand? So this is a series connection, right? So the amount of current, you can liken current to water in that analogy. So the current that is flowing here, it is the same anyway, you understand, right? But look at current, look at current. Look at current in parallel connection. This was in series. So you're going to be given two diagrams. You need to know how to interpret this one and you need to know how to interpret this one. You understand, right? Yes. So it is going to be like that. Current in parallel connection. Parallel connection. Parallel connection. We're talking about the current in parallel connection. What is happening with parallel connection? When we say things are parallel, it means those things, they are alongside each other and there is no way they will ever touch, cross or meet. They will always remain alongside each other. We know parallel lines from mathematics, right? Okay, so now, here is an example of a parallel connection. I'm teaching you while I'm being sensitive that I once taught you these things in the level. So the way I'm just explaining, those who are out there, these kids, they are not being exposed for the first time to these things. So that's why I'm explaining the way I'm explaining. Okay, thank you. You see these resistors. Resistor 1, resistor 2, right? Remember in this resistor, there is resistance. Resistance, you cannot be able to see resistance, right? But you can be able to see resistor. So there's a difference between a resistor and a resistance. It's just English. We good, it makes sense, right? Okay. So now, you see this resistor is parallel with this resistor. They are alongside each other. Three patterning, right? Huh? Okay. So, how does current behave here? How does current behave here? Let me write. Current is not the same. Current is not the same in different resistors or points in the wire. We say these things are wires, these are wires. So the current that is here, it is not the same as the current that is here, right? Okay, let's take, we say, because of this voltage, which is 2 volt, and the current that is here is 2 what? 2 amperes, right? 2 amperes. You see, this 2 amperes is the total what? Current. We good. But it does not mean that here will have 2 amperes and here will have 2 amperes. No. The current is not the same. You understand, right? What will happen? They say that parallel connection is a current divider. What will happen? The current will be divided. But it does not mean that this current will be divided like shared equally. No. It will depend. Remember, if here we've got a high amount of resistance, it means there will be what? Less amount of current, right? But the way in which the current is divided it is proportional to the what? To the resistance. I will show you when we talk about proportionality. These numbers are going to talk, they are not just going to divide anyhow. There's going to be proportionality. You understand? Of course, where there is high resistance, we expect less current. Where there is low resistance, we expect high current. You understand? So, the current that is here and the current that is here, it is not going to be the same. So, I don't want a situation whereby you are given current 2 ampere and you think, and they say calculate the voltage or calculate resistance, and you use these numbers that are here, you will be doing something which is wrong. Because the current which is here is not 2. Although the total current is 2, but the current that is here is not 2. Even the current that is here is not 2. So you need to be careful of the things which you will be doing. That's the first interpretation. The second part, not the first. The second. Current is divided in the what? In the parallel connection, right? But current is the same in the series connection. It means each and every resistor have got the same current. You understand? For the series connection, not here. I'm done talking about current. You see how current behaves? You need to put that in your mind when you are interpreting the electric circuits, right? We good, Miranda? Okay, sure. Okay, let us talk about the voltage. Let's talk about the what? Voltage. Let me just start by voltage. Voltage in parallel connection, right? When we say voltage, let's say potential difference. Potential difference. Potential difference, which is the voltage, right? Let me write voltage in brackets. Voltage. Potential difference in parallel connection. What is happening? The potential difference in one resistor is the same as the potential difference in the other resistor that are parallel to each other. That are parallel to each other. This is C. So it means if I have an electric circuit and I've got 2 resistors that are parallel, it means the voltage that is in resistor A is the same as the voltage in resistor B. That's when I'm teaching you to be able to interpret. You need to know the things. This is the third thing. You need to know. We're good, right? Okay, if we have a parallel connection like this, can you see this? If the voltage here is 2 volts, it means even here it is what? But the current is not the same. Understand, right? Yeah. And you need to be careful. You need to be careful about something. Next? You need to be careful about what? Something. You need to be careful about something. Okay, look at this. Do you see this? The voltage that is here and the voltage that is here, are they the same? No. They are not the same. You know why? Because this resistor and this resistor, they are what? They are in series. Meaning that if you want to treat this as what? You want to calculate the RP, R parallel. It means you're going to what? To do what? To add these two. And you say this one plus this one is parallel to this one. You understand? You don't treat these two as separate. You make them to be one thing. R1 plus R2. Then you say they are parallel to this one. You understand what I mean?
Yes.
Okay. Lonia, since as if she doesn't understand, can you say it, Lonia, then I can explain? Oh, I understand. Okay, thanks, Lonia. We're good, right? Of course, after doing this, I'm going to teach you how to interpret. After interpreting, then we can be ready to solve questions. We're good, right? So we need to be able to interpret. You see what is happening with the potential difference? Yes. The potential difference is the same between two resistors which are parallel. What about the potential difference in series connection? In series connection. What is happening? In series connection, the potential difference is doing what? Is different. Potential difference between resistors is not the same. Potential difference between resistors is not the same. You see this, I'm not sure whether it's 4 statements or 5 statements for interpretation that are very important. But they will not ask you to state them. You need to know them in your mind so that you are able to find the solution for any given question, because that is the way we interpret the electric circuits. You understand, right? Yeah. So go and know those statements. You are not knowing them just to be asked questions. You are knowing them to be able to interpret an electric circuit. Without knowing those statements, you won't be able to interpret an electric circuit. We're good, right? Yeah. So for this lesson 1, we are going to rest it here. Then we come for lesson 2, whereby we'll be dealing with the interpretation. After interpretation, then I can include the internal resistance and different things. But for now, we're resting it here. Go and study and make sure that you understand. If you don't understand and you're watching online, drop your question in the comment section. I will surely address it. So if you don't understand, drop your question in the comment section. Don't forget to share these videos with anyone, your WhatsApp friends, the group in your school. Share it. The main thing for us to do this is to explain to kids to understand anywhere. So please make sure that you share, you subscribe. Don't forget to subscribe to support the channel. The best thing you can do to support this channel is by subscribing. Danko. Village.